Hey everyone, this is the solution video for Worksheet 5.1. Here we're going to be talking about function composition. And in number 1, we're given two functions, f and g, and we're asked to evaluate a series of different composite functions at a specific given value. So for part A, we're asked to find g composed with f evaluated at x equals 3. Maybe an easier way to think about this is to use the alternate form of the notation for function composition. So rather than using the open circle to denote g composed with f, I'm going to write it like this. So this is equivalent for us asking g of f of 3. It's a little bit more clear when we write it like this what we're being asked to do. We want to take our function g and evaluate it at the value of f when it's evaluated at 3. So our first step is we're going to actually figure out, well, what is f of 3? That's easy enough for us to do. So we're going to take a little detour here, and we're going to evaluate our function f, which we're given at x equals 3. So f of 3, the function f is just a squaring function, so we're going to take our input 3, and we're going to square it. That'll give us 9. So this is what we're going to plug into our function g up here. So if we go back up here, what we're really being asked to do is to take g and evaluate it at f of 3, which we've just determined is actually just 9. So now we can go ahead and figure this out. So we're going to take g, which takes 2, and it's going to multiply 2 by the given input, which in this case is 9, and then add 1. So that's going to give us 18 plus 1, and that's going to give us a value of 19. So that's how we would take care of part A. So it helps to, for all of these, we're going to want to first maybe think about the alternate notation and then just go ahead and do a little sidebar to get a value. Okay, so let's try B. So here we're being asked to find f composed with g when x is equal to -1. So we'll rewrite this as f of g of -1. And we'll do a little sidebar here. So we're going to evaluate g at -1. G tells us we take 2 and multiply the input and then add 1. So that's going to give us -2 plus 1 or -1. So this is what the value we're going to take and plug back into f for our original question here. So we're going to take f, and now we're going to evaluate this at x equals -1. And f is just a squaring function, so we take that value, -1, we're going to square it, and it just gives us back a value of +1, and that would be our solution. So we're taking the output of the inside function, in this case g, and using it as the input of this outside function, f. All right, so it gets a little bit different here for part C. So here in part C, we're being asked to compose f with itself and then evaluate that at 2. So let's go ahead and give that one a try. So we write this as f of -2. So let's go down here and we'll find f of -2. So again, f, as defined in problem number 1, is just a squaring function. So we're going to take -2, we're going to square it, and that's going to give us +4. And when we go back up to our original problem, we're going to take f and evaluate it at f of -2, which we just determined was 4. And now we're going to go ahead and apply f again to this new input. So we're going to take this new value 4, we're going to square it, and then that would give us a value of 16. So that's how we would take care of that one. So for number 2, we've got the same type of problem going on here. We're given two functions f and g, and we're asked to evaluate at a specific x that we're given. So for part A, we're going to take g and compose it with f. So we'll say g of f, and then the value we're going to evaluate it at is -3. So again, let's just do a quick sidebar here, and we'll evaluate f of -3. So f in this case is the absolute value of the input -1. So that's going to give us the absolute value of -4, which will just give us back positive 4. So we're going to go ahead and use that back up with our original problem. So we're going to take G and evaluate this at our new input, positive 4. And G takes the input, in this case 4, squares it, and then subtracts 5. So that's going to give us 16 minus 5, which will give us a value of 11. So that's what we get for part A. For part B, we're going to take f, compose it with g, evaluate it at -2. So that's going to give us f of g of minus 2, which we will diligently evaluate first. So g of minus 2. Again, g we just used in part A is just going to be the input squared minus 5. So that's going to give us 4 minus 5, or a value of -1. We'll bring that back up top, and we'll go ahead and we'll calculate f of our new input, in this case -1. This is going to give us the absolute value of -1 minus 1, which will give us the absolute value of -2, which will just give us a value of positive 2. Okay, so not too bad. We see sort of what's going on here. Let's go ahead and try this last one, f composed with f of positive 2. So like last time, we're just going to take f, we're going to compose it with itself, and evaluate it at positive 2. So first, let's calculate f of 2. We take the absolute value of 2 minus 1, which is just the absolute value of positive 1, which is just going to give us 1. We bring that back up top, and we evaluate f of positive 1. And that's going to give us the absolute value of 1 minus 1, which is just the absolute value of 0, which is just 0. And that's our solution for that one. So you can kind of see the pattern with these, and it's really just a matter of keeping track of everything and making sure that you get the notation straight. Okay, so now let's go ahead and we'll move on to number 3. And in number 3, we're given two functions f and g, and we're asked to find their composite. But here, we're just going to be finding a composite function. So we're not actually going to evaluate it as specific x. We're just going to leave the x generalized as a general input x. So we want to go ahead and make sure we get the composition correct, and then make sure that we simplify it, if possible, as much as we can. All right, so let's go ahead and see what we've got here. So we want to find f composed with g of x. So this is just asking us to find f of g of x. And just like we did before, we're going to substitute in that input, in this case g of x. Now, since we're not finding an actual number, we can just go ahead and replace g of x with the actual function g of x. So in this case, it's x squared minus 9. So we're going to find f of, in this case, x squared minus 9. So we did a little bit of this when we were evaluating functions back in chapter 1. We're just going to take our function f, and anywhere that there's an x, we're going to replace it with this function g. In other words, x squared minus 9. So let's see what happens when we do that. So this means that we're going to take f. F says take 2, multiply whatever your input is. This is where the g comes into play. So that's 2 times x squared minus 9, and then add 3. So we've replaced the x in f with our g, x squared minus 9. Okay, so now all we have to do is multiply this out, see if we can combine or cancel anything, and we should be done. So let's go ahead and distribute the 2. So we'll have 2x squared minus 18, and we've got that plus 3. So we combine our two constant terms, and we'll get 2x squared minus 15. And this is our composite function. Now we could evaluate this at any x value we want to get a value, but this will be our generalized function for the composite. Okay, so let's try the same thing with number 4. So number 4, we're being asked to find, using the same two functions, g composed with f of x. Now these are not necessarily going to be the same thing, as we'll see here. So g composed with f of x means that we're going to go ahead and we're going to replace in g any x with our function f of x. notationally we would see that as, we're going to take g and we're going to evaluate it at, there we go, at this function 2x plus 3. So let's go ahead and see how this plays out. So g says take your input and square it. So in this case, what we're going to square is f, namely 2x plus 3. So we square that, and then we just subtract 9. So we've just replaced the x with our 2x plus 3, f. And when we clean this up, so we've got to square this. So we've got to multiply these two, the 2x plus 3 times 2x plus 3. That's going to give us 4x squared plus 6x plus 6x plus 9. And then we'll subtract 9 from that. And we can combine the 6x's, we can cancel out the 9's, and that's just going to give us 4x squared and then plus 12x. Okay. So that gives us our composite function g composed with f of x. Okay, so we got one more of these to do, and in number 5 we're asked to find f of g of x. So we're going to take f and we're going to evaluate it at g of x. G is, in this case, the square root of x minus 5. So we are going to calculate f of the square root of x minus 5. So we go to our function f. Everywhere that there's an x, we replace it with a root x minus 5. So we've got the quantity x, which is now the square root of x minus 5, squared, minus x. Now in this case we've got a couple x's we've got to replace, so we're going to put in that place of this other x, again, our function g, square root of x minus 5, and then we subtract 1. So notice again that we went to f, anywhere that there was an x, namely here that was x squared, and then subtract x, we replaced it with our function g. Okay, so let's clean this up and see what happens. Excuse me. So we're going to go ahead and square the square root of x minus 5. So those are going to undo each other, and that's just going to leave us with x minus 5. And there's really nothing we can do here. We're just going to have minus the square root of x minus 5. And on the outside, we've got this minus 1. So really the only thing that we can do here is we can combine these two constant terms, minus 5 and minus 1. So what we'd end up with is x minus 6 minus the square root of x minus 5. And then this would be our composite function. Not pretty, but this is what we would use if we ever needed to evaluate the composite of these two. Okay, so we've been spending a lot of time composing. What we're now going to do is we're going to think about almost like a decomposition or a breaking down of an existing composite function. This is something that we do a lot in calculus, specifically if we're doing something like the chain rule or use substitution. So something that's definitely going to help us out later on down the road. So here we're asked in number 6 to write this function p as a composite or as a composition of 2 or more identity functions. For this first one, I'm just going to stick with 2. It's going to be a little bit easier. And when they say non-identity, they're just saying you can't use y equals x as one of your functions. So don't use just x. That's the identity function. So one way we could do this is we could consider that this function p was at one point, we're kind of looking into the past here, we could have imagined that this function p of x, if it is a composition, maybe it was at one point some function f composed with some function g of x. And we want to break it down and figure out, well, what would those two functions have been when they were composed? We got this function p. So the other type of notation we would see is that f of g of x. Now the way that I like to kind of think about this is that this g, this is sort of our inside function. This is one way to think about it. So this is the function that we put inside of this outer function f. So f is sort of the outside function. We'll see how this works with an example if you haven't seen one already in class. But we kind of want to identify those. And if we looked at this function p, we've got the quantity 2x plus 3, and we take that function and we cube it. So perhaps one way we could think about it is this. So our outside function on the outside of p, we are taking some function of x we're going to generalize it. It's just we got some function of x and we're cubing it. So the outside function is taking something and cubing it. This is going to represent our function f of x. More specifically, it's some input, which we'll worry about later, cubed. Now obviously p is more complicated than this. It's not just x cubed, it's 2x plus 3 cubed. And this is where the inside part comes in. So the inside part of this function is really just, we could think of it as 2x plus 3. That's what's going on the inside. So we could let this be the g of x, the inside part, as 2x plus 3. Well, do we really buy this? Well, there's a way to double check this, which is to actually find the composition of these two. So let's check. So we notice that if, in fact, p of x is equal to f composed with g, the composition of these two functions, we've suggested that we would go ahead and we'd take f and we would plug in g. So essentially we would take this 2x plus 3, plug it in for x, and then hopefully we would get back p. Let's see if we actually get that. So p of x would have to be f of g of x. We know that we've defined g of x in this case to be 2x plus 3. And the f that we defined is just the cubing function, which is we take whatever our input is and we cube it. And this does come back to be our original p of x. So this would be sort of our breakdown here, is these two functions. This would be our solution. We can break p down as a composite of these two functions, f and g. All right, a little tricky, but it's a breaking down as opposed to a composing like we did in the previous examples. Let's try this again with number 7. So same idea. We want to write p as a composition of two or more identity functions. Non-identity functions. So here's the way that we did it before. So this is one way. Is we think of it as a composition of two functions. It's just two put together. So we could say that our outside, so if we let p of x be the composition of f and g, and I'm just going to sort of make a note here where g is the inside function. And that's directly related because it's the second one. And f is the outside function. Let's think about what this would be. Let's consider our outside function. So what's going on with this function p? Well, we've got 1 divided by 2x plus 3. So we have 1 divided by some function of x that's not the identity function. So that's a great place to start. So our outermost function is essentially 1 divided by some function of x. We will worry about this function of x in the next step. That'll be our inside function. So what we can say here is that our outside function f is just 1 divided by whatever input it, and we're going to generalize the input as x. So let's move a little bit further inside. So if we're only going to have two functions in this composition, then we need to figure out, well, what is this sum function of x we're talking about? Well, what we're doing is taking 1 and dividing it by 2x plus 3. So we make that our 2x plus 3. So g of x would be equal to 2x plus 3. And again, what we notice here is if we took these two and we said, well, the composition p of x is equal to f composed with g of x, which is the same thing as f of g of x, what we'd be doing here is we'd be taking the function g and plugging it into f. So we take g, which is 2x plus 3, plug it in to f to get 1 over 2x plus 3. Let's check that out to make sure that works. So we take f of g, which is 2x plus 3, and f just says take 1 and divide it by the input. So we've got 1 divided by 2x plus 3, which is our p of x. So that's a perfectly great way to go about doing this. If you were feeling a little adventurous and you wanted to explore this or more way of composing it, this one could be composed with 3 functions. So I'm going to go ahead and we're just going to show you this another way to put this together. So what we're going to do, the one difference we're going to stay is in our statement we're going to let this function p of x actually be a composition of 3 functions. We're going to say it's f composed with g composed with a third function h of x. So what we've got now is h is still the inside function, and f, sort of like the bookends, that's still the outermost function. But then we've got this g, which is sort of in between, an in-between function. And again, I like to think of these as as inside and outside, kind of like those Russian nesting dolls where you put one shell inside of another shell inside of another shell, and you can break it up this way. That's kind of what we're doing here with functions. Is we've got an inside function, and then we put another function on the outside of that, and then another function on the outside of that to get a whole composite function. So let's see if we can get something to work here. So let's consider our outermost function, so the most outside. So outside. Well, we can kind of reuse the last one. If we look at this function p, we've got 1 divided by some function of x. Okay, so we're going to go ahead and we're going to stick with letting f of x be 1 over whatever we choose to put in. Now, let's think about the in-between one. Well, we've got, if we go back to p, we've got 1 over 2x plus 3. Well, we could think of this in-between function as a sum function of x, and then we're just adding 3 to it. So maybe what we could do is we could let g of x be defined as just x plus 3. Well, we don't quite have all the pieces together, so maybe this most inside function that we have could be 2 times, and then we run out of functions of x. We've just got the identity function x. So this will be our h of x. So if we let h be equal to 2x, all of a sudden we've set up this chain of events where if we start plugging these functions into each other, well, in place of the x, we're going to plug 2 in for this x, and then that's going to give us 2x plus 3, which we'll then take and then plug in to this function. So all of these will sort of link up in that fashion. Let's see if it actually works out for us. So if we compose all 3 of these together, so we're going to compose f with g with h of x. So we'd have f composed with g composed with 2x. Well, if we take g, which is x plus 3, and plug in a 2x, it's going to give us 2x plus 3. And then f says take whatever your input is and put it under 1. So that's going to give us 1 over 2x plus 3, which is our function p of x, which is exactly what we wanted. So these would be our three individual functions for that one. Okay, so that takes care of this solution video, and we'll see you all in the next one.